We're going to continue on with chapter 3.3. We're going to look at subtraction now. So it's first important to think about the situation of what does 7 minus 2 mean, and if you had to come up with a word problem, what would you come up with? Ultimately, your word problems, if you create them and compared it with others, you would be solving it again, how you would go about solving it could take on a couple of different ways depending upon what the word problem is, right? And so one way we can first that we look at approaches to subtraction, one is through the takeaway approach, right? And that's kind of what you're used to from elementary school, right? The problem, if you have 5 coins and spend 2, how many do you have left, can be solved using what's called the set model and the takeaway approach, right? If you walk 5 miles from home and turn back to walk 2 miles, how many miles are you away from home? Again, this is a takeaway approach, but you could use a measurement model, a number line going 5, back 2. Here's 5, take out 2. Those are important ways to distinguish how to solve approaches for subtraction. And so what is our definition? We go back to a set definition, right? It's the number of objects from A minus B when you look at how many objects are in A and B. And so in this case, the number A minus B, we call that the difference. And so when you say that's the answer, right, when you subtract at A minus B, that's how you would say it. Again, not as important, minuend and subtractand. Most people forget those terms, but again, those are the values in a subtraction problem. And so that's one way to solve a problem, a subtraction problem, is through that takeaway approach. Another way is called the missing addend approach. And it's kind of the counting up. Here's the definition for subtraction, though, another alternative definition. A minus B equals C if and only if A is equal to B plus C, that there's an interplay between those values there. So it's important to recognize that interplay between, you say, if you do A minus B equals C, that's again equivalent to saying A is equal to B plus C. And that's from algebra also, add B to both sides and you can get that. But there's this missing addend approach. Here are 4 word problems that connect those different types, right? A missing addend approach, a takeaway approach, measurement model, and set models that you could be used to answer those questions. But again, important is understanding when are you really adding to solve an addition problem and when are you just taking away to solve an addition problem. And so what we mean by that is, again, you could on the problem up here on the top, you did we did 100 minus 76. We know that equals 24, right? But in this case, you also know that 76 plus what equals 100, and that's how you would solve that problem, right? 76 plus 24 equals 100, so 100 minus 76 is 24. That's that missing addend approach and the definition there. And then the last subtle thing is that when we do some of these problems, when we're subtracting, we have something called a comparison. Is there a comparison being made? And so it's another way of viewing subtraction. And in this case here, as you read these 2 word problems, right, you're considering these 2, there's a new aspect to this problem, right? Instead of considering how much taller Monica is than she was last year, you're asking her to compare her height with another player. And so more generally, you might want to compare her height to all the members, right? This way of viewing subtraction adds a 3rd dimension to this, which is comparison. But again, just you want to be aware of that as you recognize what type of subtraction problem, how do I solve it, missing addend, right? Am I going to take away? But subtraction is used in those scenarios and being able to recognize that. And then lastly, we have some practice problems, and I realize now that these are the same ones that we just did above, so we don't have to do those. And looking at, again, thinking ways of doing 8 plus 5. You can see how that gets broken up. You can see a visual of that. What's another way to think about 8 plus 5? How else could you break 8 plus 5? They did 8 plus 2 plus 3. What's another way to do that? This problem. The first thing that comes to mind is that it's 3 plus 5 plus 5, 13, is that I'm going to put the 5s together out of that 8, right? And then again, since we said we did those up above, we have these subtraction ones that we can look at real quick. 22 minus 7 can be solved. 7 plus what equals 22? And you can count up to 3 is 10, plus 10 more is 20, plus 2, so there's your 15. Or you could just subtract, take away. Same thing here, multiple ways to look at it. 59 plus what equals 101? I'm going to add the 1 to 60, plus 40, plus 1, and so then now you have your answer of 42. And then again, similar problems for base 5. How would you solve those problems there? I could just count up for 1, 0, 1, 1, 1, 2. Here we could use a measurement model and take away. There is your 1, 2, and then take away 3, 1, 2, 3. So your answer is 4 in that case, which you can see should be related over here. 3 plus 4 equals 1, 2 base 5. 1, 2 minus 3 equals 4. So important to recognize that.